Okay, let's take a look at the last question from the most recent homework. I know this one's driving some people nuts. It's a word problem. There's a lot to it, so grab yourself a drink, sit down, hold on tight. We're in for well, not a bumpy ride, but a lengthy one. So this question asks about hamburgers at the city sports arena. So some information that we need. The hamburgers are selling for $3 a piece. So these are our hamburgers. And they sold an average of 500 hamburgers on game night when they did that. So sold 500. Okay. When the price was raised to $3.40, so $3.40, then they sold an average of 400 per night. Their fixed cost, so the fixed cost, I'll write that over here, make sure you can still see it. Fixed cost, so just probably like their rent or whatever, electricity, people to man the food concession stand, that was $615.60 per night. And the variable cost was $1 per hamburger. Okay, so every hamburger that they sold cost them $1. They started out charging $3 and were selling 500 of them a night. They changed to charging $3.40. They were selling 400 of them a night. And again, fixed cost is $615.60 and the variable cost is 100. And the first thing that they're going to ask us is to express p as a function of x and find the domain of this function. So A, we need to express p as a function of x. Okay? And so what we're looking for, since they're actually telling us that this demand, the relationship between price and demand is linear. So we're going to have to come up with the equation of a line, basically. And the way that we're going to do that is to come up with an equation for the slope of the line. Yeah, that's what I was looking for. Slope of the line. So P is price and demand D is X. So I'm going to actually write these in ordered pairs. X, comma, P. All right, so this was X and this was P. That's when it was selling for a price of $3. They sold 500 of them a night. And now another X, comma, P. Oops, I wrote P. 3.4. And again, those were the two things that are related linearly. And I know that's kind of out of the order that I wrote them in before, but I'm trying to keep track of what X is and what P is. And P kind of acts like our Y here. So we need to find our slope. And our slope in this case, and we'll call this one, what are we going to call it? X1, P1, X2, P2. So our slope is going to be P2 minus P1 over X2 minus X1. Okay? So that's going to give me 3.4 minus 3.0 over 400 minus 500. And if you plug that into your calculator, you are going to get negative 0.004. All right, so that's the slope, but that's still not quite the equation of the line. We need a little bit more. So what we have to do is use the point slope form of the equation of a line. So what we're going to do here, again, we're going to use p's instead of y's. And I know that seems a little bit weird because we're so used to the y minus y1. But here we're going to do p minus p1 equals m times x minus x1. And this is just the point slope form of the equation of a line. And I'm using p's instead of y's because these are price functions, price demand functions, and we're talking about p for price instead of y. So now I go ahead and plug in these 2 points. So p minus p1, that's 3, equals m. Well, we found that slope. That's negative 0.004 times x minus x1, that's 500. I can simplify that a little. P minus 3 equals negative 0.004x. And if you multiply negative 0.004 times 500, or negative 500, you're going to get a positive 2. All right, and then if I bring that 3 over, I'm going to get 5 minus 0.004x. All right, so that is my price demand function. And so you'll enter that in, and they also want the domain of the price demand function. So this here, this is the price demand function. All right, and the domain of this is anytime, what we do is we set this side of it equal to 0, and anything between 0 and that number is going to be the domain. So we do 5 minus, and I'll write domain here so that we know what we're looking at. 5 minus 0.004x equals 0. All right, well, that means that 5 equals negative, or not negative, I brought it over, 0.004x. I'm going to divide both sides, and that's going to give me x equals 1,250. And again, you can plug that into your calculator, but what that tells me is that the domain is going to be everything where my x is between 0 and 1250. And the good news is they're going to ask you for another domain in a second, and that domain is exactly the same. So once we found this, we don't have to find it again. Okay, so that, I believe, takes care of part A. Now we need to move on to part B. So part B, they're asking for the revenue function. So they want the revenue function in terms of x. And lucky for everyone involved, you and me both, the revenue function is really easy to find if you have the price-demand equation. The formula is just going to be that the revenue function equals x times that price-demand function that we just found. Okay, and the price-demand function was this P equals 5 minus 0.04x. So we're just going to do R of x equals x times exactly what we found, that 5 minus 0.004x. And if we expand that out, that'll give us 5x minus 0.004x squared. Okay, so that is our revenue function, and they ask for the domain, and like I said, it's going to be the same as it was for the price demand function. So in this case, it works for every x between 0 and 1250. And the thing is, you can't have a negative number there. It doesn't make sense for it to be a negative number, and so that's why we set that equal to 0 and solve for that to find the domain. All right, so we need to now go on to part C. And here they say that we need to assume that the cost function is linear, and we need to express cost in terms of x. So what they want is a cost function. And what we had here were these costs. These were our costs that we found earlier. So we had a fixed cost and a variable cost. And all we're going to do is use those to make our cost function. So C of x is going to be our fixed cost, that's $6.15.60 that they have to pay every single night that they run the concession stand, plus 1 times x, $1 for every hamburger that they sell. So that's our cost function. I guess we could simplify that a little bit. $6.15.60 plus x. Okay, and that is our cost function. So that's actually kind of simple as long as you know where to find those costs in the word problem. So now on to part D. part D, they're going to ask you to graph the cost function and the revenue in the same coordinate system. And actually, let me look at this problem in the actual homework because I have not done that. I'm not sure if they ask you to pick out a graph that makes sense, or let's see. Let me. I apologize for the slowness here. I'm going to push some buttons and make it take me through the problem really quickly. This is a time when I wish I knew some good jokes, because I'm certainly not going to go back to the beginning of this and start all over again. Let's see. Almost there, I promise. Almost there. You can fast forward through this part and eventually I'll start writing on the piece of paper again. Unfortunately, my cell phone does not allow me to edit this nearly as well as I did. Oh, okay, so they want you to graph the cost and the revenue on the same coordinate system, and they want you to choose the right graph that makes sense for that. So here's how I would look at this, because they're going to give you a whole bunch of graphs to choose from. I know that, let's see, the cost function, let me look at that cost function. The cost function is, yeah, that's not what the cost function is. All right. So the cost function I know is linear, and it goes through like $615. It's going to look something like that. It's got a positive slope. It's going up in a straight line. So that's the first thing that you're going to look out for. And then they also want us to graph the revenue function. The revenue function is a negative parabola, and a negative parabola is one that does this. And again, my picture's not perfect here. I didn't go through everything correctly, but there should be only one picture that kind of matches that, where you have a straight line that is increasing and a negative parabola. And that's the graph that you're looking for here. Honestly, my parabola should have been shifted over a little bit. So you're going to pick that picture because that's the one that represents what we're talking about here. And then what they're going to ask you for are the break-even points. Now, there is no way that we can find these break-even points just by looking at the picture of the graph. I really, really wish it was that simple, but it's not, unfortunately. What we're going to have to do is use the quadratic formula. So the break-even points, and let me move on to another sheet of paper here. For the break-even points, break-even points. All right, we're going to have to set C of x equal to R of x and solve for x. So we had our cost function and our revenue function. Those were, let's see, C of x was 615.60 plus x, and our revenue function was 5x minus 0.004 x squared. And so I know we're going to have to use a quadratic formula because this is not going to factor. It's just, I mean, we've got too many decimals floating around. It's not pretty. So let's rewrite this in a way that we can use the quadratic formula on it. And so if I bring everything over to this side, I'm going to end up with 0.004 x squared minus 4x, that 5x, subtract that over here, and that's going to give me negative 4x, plus 615.60 equals 0. And so now I need to use a quadratic formula. And this is, it's not pretty. It's something you might want to enter into your calculator a couple of times to make sure you're entering it correctly. But definitely memorize this. So the quadratic formula, you will need it on tests in the future, so you can't just kind of ignore it. This is a fact of life. Quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. And a is the coefficient on the squared term, b is the coefficient on the term where it's just x to the first power, and c is the coefficient on that constant term. Okay, so we continue now by filling everything in. So in this case, negative b, well, my b is negative 4. So negative, negative, that's actually a positive, and so we can kind of get rid of that plus sign there. I just want you to see where that came from and went to. And then we have plus or minus the square root of b squared. Well, negative 4 squared is going to be the exact same as 4 squared. It really doesn't matter, and I can actually, let's put a negative 4 in there. Minus 4 times a, that's 0.004. Make sure you can still see what I'm writing. C, which is 6/1560. All right, and that's going to go all over 2 times 0.004. So I just used these numbers to fill in my quadratic formula. And if you simplify it, you can kind of do it in bits and pieces if you want to. Maybe you take care of the square root here first. That's going to give you 4 plus or minus 2.48 over 0.008. So the two things that you have to look at is 4 plus 2.48 over 0.008 and 4 minus 2.48 over 0.008. So we have to solve those. And that's going to give us x equals 190 or x equals 810 if you plug all of that into everything. So quadratic formula, not fun at all. But that tells us now that our break-even points are when the demand is 190 hamburgers or 810 hamburgers. Now they want us to find the cost of each of these demand values by substituting them into the cost function. So, on to another sheet of paper. I told you this was epic. We need to figure out cost at 190, and we need to figure out cost at 810. So we use our cost function. If I can find the sheet of paper, that was 615.60 plus x. So in this case, that'll be 190. And now we have 615.60 plus 810. And so what we end up with here is 805.60. What we end up with here is 1425.60. So our break-even points are, if x equals 190, we're doing this as an ordered pair, it's 805.60. If x equals 810, it's 1425.60. So those are our break-even points. Are we done? Not yet. So we keep going. Part E wants us to find the profit function in terms of x. Fortunately, that's not too bad. So the profit function, capital P of x, that's going to be the revenue function minus the cost function. And that makes perfect sense. How much money we pull in each night minus how much it costs us to operate. That's telling us our profit. It's our revenue minus our costs. So that's just going to be the revenue function that we had before. So the 5x minus 0.004x squared minus the cost function. Now, a mistake a lot of people make is they don't put parentheses around the cost function. Put parentheses around the cost function, because otherwise you'll forget to distribute this minus sign. So my cost function, that was 615.60 plus x. And so now if I distribute everything out and collect my like terms, I'm going to get negative 0.004 x squared plus 4x minus 615.60. And you can see if you forgot to put the parentheses around here, you would have added the x to the 5x and gotten a 6x here, and that would have been wrong. So always make sure to put parentheses when you're subtracting that cost function. Okay, finally, we have one more thing that we need to do. We need to evaluate the marginal profit at x equals 430 and interpret the results. So, if only that was as easy as sticking 430 into something. But first we've got to come up with the thing to stick 430 into. So, they want marginal profit, and what that tells me is that I need to take the derivative of my cost function. Anytime you see the word marginal, that means you've got to take the derivative of something. So we need to find, first of all, we need to find p prime of x, the derivative of our profit function. So that is going to be negative 0.008x. All I did was multiply the exponent by what was out in front of the x, copy down the x, and subtract 1 from the exponent. So that just left me with x to the first power plus 4, and that negative 61560, that goes away entirely. That just becomes 0. So here is my marginal profit, but they want me to evaluate that at 430, so I need p prime of 430, and that's going to be negative 0.008x, or not x, I'm evaluating it, 430 plus 4, and when you plug that into your calculator, you are going to get a whopping 56. Okay, so that's 56 cents. And what this means is that at a production level of 430 hamburgers, the profit is increasing at a rate of 56 cents per hamburger. That's the interpretation here. Marginal always tells us when we're looking at marginal profit or marginal cost or marginal revenue, those are all rates that something is changing. So you always want to look for a rate of change, or increasing at a rate or decreasing at a rate when they're talking about interpreting a marginal function. In this case it was marginal profit, and we had a positive 56, so that meant that when we are at a production level of 430 hamburgers, the profit is increasing at a rate of 56 cents per hamburger. And we're done. We're done. Feel free to rewind, fast forward, whatever you need to do to get it, and please, please, please don't blow off the quadratic formula. You're going to need to be able to use that in testing situations, so make sure you've got a solid grip on it, practice it a couple times a week. It's probably, well, it's not my least favorite thing to use, but it's up there. It's not something that looks pretty on a piece of paper when you start throwing all those decimals into it, but it is an absolute necessity here. So that will do it for this one, which I hope is the longest video, that I don't have to ever make anything quite that long again, but I know that's not true because we've got some interesting stuff coming up in a couple of weeks.